All right, so today we're going to be going over section 4.3, and 4.3 is all about the graphs of tangent and cotangent. Okay, now before I get into all of this, I just want to remind you that when we are looking at the unit circle, right, the xy points that we have all the way around, the x and y, are defined by the cosine value of that angle and the sine value of that angle, right? And when we talk about tangent, tangent can be calculated by finding the y value divided by the x value. Okay, so you can look back in your notes at section 3.3 for the unit circle and look at it that way, but I'm going to go ahead and just put my generic one here, and let's just talk about it for a second. So if we are going to be using tangent values, meaning we're taking y values and we are dividing them by x values, right? Notice here we don't have an issue at 0 or at 2 pi, right? Because if I do my y value, which is 0 divided by 1, that's just 0. But when I go up to my next quadrantal angle, which is 0, 1, if I try to divide my x and y values here, if I do y divided by x, I'm doing 1 divided by 0, which is undefined, right? I can't actually get a tangent value for pi over 2. And the same thing happens down here at 3 pi over 2, right? 3 pi over 2 also has an x value of 0. Right? So wherever we have an x value of 0, when we calculate tangent, that 0 ends up on the bottom of the fraction, making it undefined. So what that tells me is I can't make a normal full 2 pi rotation for a tangent curve, because I'm going to run into this problem at pi over 2 and again at 3 pi over 2, where I have something that's undefined. And when we run into an area that's undefined, what that does is it creates an asymptote on our graph. Okay, so we're going to end up with an asymptote at pi over 2 and also at 3 pi over 2. So I want to look at, I still need 5 good values to use to come up with my tangent curve, but I just can't use the same 5 that we've been using to go all the way around the circle, right? So what I'm going to think about is, if I end up with an asymptote at pi over 2, or an issue here at pi over 2, and I know I have an issue down here at 3 pi over 2, then my tangent cycle, or my tangent curve, is only going to be a half rotation, right? So I can use this half of the unit circle, or I could use this half of the unit circle, right? So I'm going to use this half of the unit circle just because we usually start, you know, at 0 and go from there. But I have to stop when I hit an asymptote, right? So I'm going to go ahead and label what's going on this side, and then I'll also use this half of the unit circle, okay? So just to explain what I'm doing, I need to find 5 points that fall on just 1/2 of the unit circle. Okay, and again, because we can't use those quadrantal points, that's unfortunate, right? But we can still find points that give us nice, pretty tangent values. Okay, so remember, tangent is y over x. So if you look at that unit circle that we did back in section 3.3, you'll be able to see that our 45-degree angles, right, or our pi over 4 angles, actually have the same x and y value. So if I were to calculate the tangent by doing y divided by x, right, this is the same number divided by the same number, that's just going to give me 1. So that's a really nice, pretty value I could use. So even though I don't have a quadrantal angle, I could use this angle of pi over 4, right? So I have my undefined pi over 2, which I know is going to give me an asymptote. And the way that we denote asymptotes is with a dotted line. So I put this here just kind of for reference. So we have our undefined tangent, but at pi over 4, we have a nice pretty tangent value, because if I divide these, that's going to give me 1, right? I also have a pretty tangent value at 0, right? Because at 0, I can do my y divided by my x, and 0 divided by 1 is just 0. So at 0, I get a nice pretty value. And then I can continue down here. Now, because we want this to look like one pretty cycle, instead of labeling these with angles coming in the counterclockwise direction, I'm going to go ahead and just assume we're coming from top to bottom, right? Or from bottom to top, meaning I'm going to go from negative pi over 2 up to pi over 2, right? Instead of labeling these with 3 pi over 2 and whatever this pi over 4 one would be, right? 7 pi over 4, I guess. Because, again, I'm using that 45-degree angle because now these are all evenly spaced, pi over 4, right? And I'm picking ones that have nice, easy values. My undefined ones at my pi over 2 and negative pi over 2. My values that's going to give me a positive 1 or a negative 1 when I divide and calculate my tangent. And then at 0, I know that y divided by x gives me 0. So these are the 5 points that I'm going to use for my tangent curve. Okay, so I'm going to refer back to this unit circle, but I want to go ahead and start filling in our notes. So if we look at the values of tangent, which we get by doing y over x as we go around the unit circle, remember at 0, I wonder if I can put both these things on here, maybe. Can I make them both fit? Possibly. Possibly. Alright, so when we look at 0, right, if we want to calculate y over x, that would be 0 over 1, which is just 0. So that's a nice angle, right? As we move up to pi over 4, right, we're getting square root of 2 over 2 divided by square root of 2 over 2. Now, I'm not going to write all that out because it's a tiny little space, but I want to say basically we're getting the same number divided by the same number, which gives us a 1, right? So if I divide this y over this x, that just equals 1. And then when I go up to pi over 2, right, if I divide y by x, I get 1 over 0, right, which is undefined. So anytime I get an undefined value, this tells me this is where I'm going to have my asymptote, okay? All right, and then I still need this other half of my rotation here. So I'm going to go ahead and just label this negative pi over 4 and negative pi over 2, okay? And then if I look at what values I would get for their tangent values, here, again, I'm dividing the same number by the same number, but the y one is negative. So I'm doing negative the same number divided by the same number, because I just don't think I can fit writing this number divided by itself in this small space. But you can see here, these are the same number, right? It's just the y value is negative. So any number over itself is 1. Since the top is negative, this is going to give me a negative 1. And then at pi, oops, I forgot my, at pi over 2, sorry, negative pi over 2 rather, that's going to be this bottom part of the y-axis, right? And when we come down here, again, our tangent value when we do our y divided by our x, that's negative 1 divided by 0, which is undefined, okay? And when we have an undefined, value, that tells us that's where we're going to have an asymptote, okay? All right, and I'm going to write this out prettier than how this is, because I'd really like for it to go from negative pi over 2 to negative pi over 4 to 0 to pi over 4 to pi over 2. Like, I'd like for it to be in order. But I want y'all to be able to see the values, okay? So we're going to go ahead and go by pi's over 4. So here we have pi over 4, and then we have 2 pi over 4, right? 2 pi over 4, which is just pi over 2. And then we have those in the opposite direction, right? We have 0, and then we have negative pi over 4, and negative 2 pi over 4, which again is just negative pi over 2. So here's our 5 values, 1, 2, 3, 4, 5. And we know at negative pi over 2 and positive pi over 2, we have undefined values, which means we have asymptotes. So I'm going to go ahead and just draw in dotted lines. Asymptotes are lines that we cannot touch or cross. Okay, they kind of keep our graph within a bound, right? Now our graph can get infinitely close to these asymptotes, but it cannot touch or cross. Okay, all right, so let's go ahead and put in our values. For negative pi over 4, we're down at negative 1. So I'm just going to go ahead and say this is negative 1, this is positive 1. So negative pi over 4, we're down at negative 1. At 0, we're at 0. Right. Excuse me. And at pi over 4, we're up at positive 1. So although this could possibly kind of be connected as a straight line, it actually jogs over a little bit in the middle. And then as you draw it up and down, we want to make sure that you draw it towards your asymptotes. So this side is going to increase on towards that asymptote. This side's going to increase or decrease down towards that one. Okay, so notice it should come up and kind of have a little jog over, something like that. So this is what our tangent curve looks like. Okay, so notice here the period of a tangent curve, in order to get this entire little swooshy looking shape, right, it's going from negative pi over 2 to pi over 2, right? So there's half of a pi on this side and half of a pi on this side, which means the entire period length is going to be pi. Okay, so the period length is different from sine and cosine. Okay, so I'm just going to say here that we go from negative pi over 2 to positive pi over 2. Okay, that's how I got the period length of pi. Okay, so if we're trying to solve for our period length, right, we still find b in our equation, but instead of doing 2 pi divided by b, we'll do pi divided by the absolute value of b. Okay, so this is an important thing to note if you're making note cards to help you remember these shapes. The things that I would put on the note card is, you know, for a sine curve, we start at 0, and then, you know, right, we started with no sin, right? And then it increases to 1, then back down to 0, then negative 1, then back up to 0, right? We know what a sine curve looks like. For cosine, that's our cough, right? So it starts up at 1, goes down to 0, then down to negative 1, back up to 0, and ends up at 1. For tangent, okay, what I would say is it's just an increasing function, right? Notice it's just from left to right. If I trace this with my finger, it's just going to keep getting bigger and bigger and bigger. So the way that I remember this is I think tan kind of sounds like band. Okay, it really doesn't. But I want you to think of it as band on the run. Okay, band on the run. Have you heard that song? Band on the run. Right? Okay, I don't sing. Anyways, but think about it as somebody who's on the run. There's no bounds. The sky's the limit. They could go anywhere, right? So think about that as if you look at these values, it's increasing. It's going from negative 1 to 0 to 1, right? Negative 1 to 0 to 1. So we're starting down low, and then because we're a band on the run, we're a tan on the run, right? Then our sky's the limit. It's just going to keep going up and up and up. So we'll work these the same way that we worked our sine and cosine graphs. We'll adjust whatever is inside the function so that we have a good starting and ending point that will give us these nice pretty values. So once we have all 5 points, we know that our first and last points are always going to be the asymptotes, and that the intermediate points is where we're going to plot our -1, 0, 1. Okay? All right. So the difference here, I think I said this, but I didn't write it. The difference from sine cosine graphs is that the period is 2 pi over the absolute b, right, for sine and cosine, and for tangent, it's going to be pi over b. Okay, so the process of going through this and graphing it is going to be very, 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 very similar. The only thing is we have to remember that our period is a little bit shorter because it got cut off with those asymptotes. Okay, all right, so let's go ahead and look at an example. Now, as we look at this first example, I am going to kind of refresh us on all the things that we learned last time. Okay, so last time, and I'm going to write it as a tangent function, we have y is equal to c plus a tangent of b times x minus d. Okay, so this is what our equation looks like, and I just want to refresh you on what all the little letters stand for, right? So let's look at each of these. We know that A has to do with our amplitude, right? And our amplitude is where we get our vertical scaling, okay? Vertical scaling. And you can think of this as our amplitude. That's what we called it when it's a sine and cosine curve, because the amplitude is the distance from the vertical center up to the max, or the vertical center down to the bottom. But with tangent, because it keeps going and going in both directions, it keeps getting taller and longer, we don't actually have a defined amplitude. So we're going to call this vertical scaling, so to let us know how much it's being stretched, if it's being stretched at all. Okay? Inside here, our B, remember, is where we get our period, right? We're going to get our period from pi over the absolute value of B, right? If there happens to be no B in there, we don't have to worry about that, right? But if there's being something added or subtracted in here where D is, right, once we've factored the B off, remember that's very important, this is our phase shift, right? This tells us if we're going left or right, okay? And then the last one we had is the one that I made a big mess by. But our C, if we're adding or subtracting outside the function, right, this is going to be our up-down shift, okay, our vertical shifting. So this tells us if we're going up or down, okay? All right. So all the same idea, the only difference is instead of saying amplitude, they're going to use the verbiage vertical scaling now for our A. I think that's it. And we have to remember that our period is only a length of pi. So let's go ahead and check this one out. Okay. First thing I want to do is determine how we need to adjust our x's. So I'm going to go ahead and take whatever is inside that tangent function, and I'm going to put it between what I know to be our normal tangent curve, our normal tangent cycle, right? So if you look back on the other page, our normal tangent cycle goes from negative pi over 2 to pi over 2, right? So that's what I'm going to adjust my x's with. I want to make sure that my function goes from negative pi over 2 to positive pi over 2. And now I'm just going to adjust my x's so that I get those nice, pretty values, right? So the only thing that's being done inside here to my x is it's being multiplied by a third or divided by 3, right? So to undo that, I'm just going to multiply by 3. And remember, if we multiply by 3 on the inside, we have to multiply by 3 everywhere, right? Okay, so on the inside, my 3's will cancel. And now I have negative 3 pi over 2 is less than or equal to x is less than or equal to positive 3 pi over 2. Okay. All right, so now I know where my values are going to start and stop. I'm going to come back and do the vertical scaling in the period in just a second, but I want to go ahead and fill in my values. So this is my starting point, and this is my ending point. So we're going to start at negative 3 pi over 2, and we're going to end at positive 3 pi over 2. Now this one should be very easy to find the center point, right? Because these are the exact same values except one's positive and one's negative, which means our absolute center is at 0, right? And then I should also pretty easily be able to figure out my other two values by just figuring out what is halfway between 0 and 3 pi over 2, right? So if I want to find my other values, find other points, I want to know what's halfway between 0 and 3 pi over 2. Well, to find the halfway point, you can either divide this by 2 or you can average these, right? Whichever. I'm going to go ahead and model it as averaging just because that's how we've done it up to this point. So if I want to average 0 and 3 pi over 2, I would do 0 plus 3 pi over 2 and then divide that by 2, right? Again, 0 plus 3 pi over 2 is just 3 pi over 2. And then when I divide it by 2, right, that's like 2 over 1, I flip and multiply by the reciprocal, which gives me 3 pi's over 4. So that's my intermediate point here. And it also tells me what my intermediate point is here. I just have to make it negative. Negative 3 pi over 4. Okay. So when I fill in my chart down here, 4 is the smaller denominator, right? Pi's over 4. So I'm going to go ahead and count by pi's over 4. Excuse me. So here's 1 pi over 4. 2 pi over 4 would be pi over 2. And then 3 pi's over 4. 4 pi's over 4 would be pi. Oh, I'm sorry. Let me scoot this up so you can see what I'm doing. I apologize. Okay. And I need to keep going until I get to my ending point here. So what was I at? This was 4 pi's over 4. And then I have 5 pi's. No, 4. Yeah. 5 pi's over 4. And then I have 6 pi's over 4, which actually reduces to 3 pi over 2. Okay, and I can stop there because that's my ending point. So now I just need to do all these same values, but in the opposite direction, right? So here's negative pi over 4, negative pi over 2, negative 3 pi over 4, negative pi, negative 5 pi over 4, and negative 3 pi over 2. Okay, so I counted by pi's over 4 so that my graph is nice and easy to label, but I only need the 5 points that I have written up here. So I have my negative 3 pi over 2, my negative 3 pi over 4, I have 0, I have 3 pi over 4, and I have 3 pi over 2. Okay. All right, so we know, since there's nothing else going on and we have adjusted our x's to give us those nice, pretty values, we know that our tangent curve starts with an asymptote and it ends with an asymptote, right? And then when we we label ours in, remember it's band on the run, right? Tan on the run. So we start down at -1, go up to 0, and then up to 1, and it keeps going. So let's go ahead and draw in our graph. So we're going to go ahead and say, I'm actually going to draw this up a little bit. That way we can see the points better. I'm going to say this is 1, this is -1. So at negative 3 pi's over 2, that's where our asymptote is. Right? At negative 3 pi over 4, we're down at 1. 0, we're at 0. And 3 pi over 4, we're up at positive 1. So remember, we always connect our dots headed towards the asymptotes. So this one's going to go this direction, headed towards that asymptote. And this one's going to head this direction towards that asymptote. Okay? So I end up with a nice, pretty picture. So I want to go ahead and go back up and fill in all the information it's going to ask me about this, like what is the vertical scaling or my amplitude, what's the period, do I have reflections or phase shifts or any of that stuff. So let's go ahead and go back up here and look. So vertical scaling, remember that comes from this A value, anything we're multiplying by on the outside of the function. Right? And notice here, we don't have anything being multiplied outside the function. So for vertical scaling, we have none. And I'm just writing it on this side because I have too much stuff going on over here. Okay? For our period length, okay, we take our normal period length, which is pi, and we divide it by the absolute value of b. Okay? So that gives me pi divided by my b value. If I look inside the function, what's being multiplied to my x, I have 1/3, right? And the absolute value of 1/3 is just 1/3. So I'm going to go ahead and flip and multiply. So pi times 3 over 1 is 3 pi. So that is my period length. Okay. Which makes sense if you look at your picture, right? Because this is half of 3 pi, right? We went to negative 3 pi over 2. This is half of 3 pi. This is half of 3 pi. So if I add these two together, that's going to give me a total distance of 3 pi. So that's my period length. Then I want to see, do I have any reflections? Right? In this case, I don't. I look to see if that a value is negative. Do I have a negative in front of my tangent function? And here I don't. So no. Phase shift is, am I adding or subtracting inside the function? And if I look here, nope, I'm not. And then our vertical shift is, am I adding or subtracting outside the function? And notice here, I'm not. So no. Okay. So notice the process is pretty much exactly the same. The only thing we have to remember is that our starting period length is pi. And we have to remember our new set of pretty values in order to get our tangent curve, which is asymptote, -1, 0, 1 asymptote. Okay? All right. Let's try another one. And I'm going to go ahead and say, so for this example on page 3, this page 3 has you do the problem, and then on page 4, it says extend the graph that we just did on the other page. I'm going to mark that out because I'm going to go ahead and extend the graph 2 periods on page 3, okay? And then on page 4, I'm going to write in a problem for y'all to try, okay? So let's just go ahead and do this problem, and then I'll extend it an extra period, and then I'll give y'all one to try, okay? All right, so I want to go ahead and write in the things that I know, okay? First thing is I notice that there is a negative being multiplied, okay? That tells me that there's going to be a reflection. So I can go ahead and down here say there's going to be a reflection about the x-axis, right? Because I can already see that negative. The 1/2 refers to my a value, right? Which was formerly our amplitude, which is now our vertical scaling. Okay. So vertical scaling, I'm going to go ahead and put as 1/2. Okay. And then we want to go ahead and find our period. Remember, our period, we do pi over the absolute value of b. So in this case, we're going to do pi divided by the absolute value of 2, because that's our b value, right? So our period length is pi over 2. So notice that's half of what it normally is, right? Because a tangent cycle is normally a length of pi. So let's go ahead and adjust. Let's go ahead and adjust our x values to make sure that they fall in that pi over 2 period length. So we're going to take whatever is inside our tangent, and we're going to put it between our regular starting and ending point. So remember, we normally start at negative pi over 2, and we normally end at pi over 2, right? That's our little half, or full cycle for tangent, but half the unit circle, right? So when we adjust for our x's, we're going to have to divide everything by 2. Now, normally I would just put a line and say divide by 2, but I have fractions over here. So instead of saying divide by 2, dividing by 2 is the same as multiplying by 1/2. So I'm going to do 1/2 times negative pi over 2, 1/2 by 2x, and 1/2 times pi over 2. Okay. That way my 2 and my half cancel, and what this tells me is that now my function is going to go from negative pi over 4 to positive pi over 4. Okay, so this is my start, this is the end. Okay, so I'm going to go ahead and fill in with my start and end values on my chart here. So I know I'm going to start at negative pi over 4. I'm going to end at positive pi over 4. I should be able to fill in my other values relatively easy, right? These are exact opposites, which means that in the center I should have 0. And I also should be able to figure out what's halfway between pi over 4 and 0. If you're not sure, you can average them, but half of pi over 4 should be pi over 8, right? So this is going to give me a pi over 8. And on the negative side, a negative pi over 8. Okay, so I've adjusted my values, my x values, so that I get those pretty values, the nice y values, right? I'm going to say these are our nice y values. So our nice y values is that we start with an asymptote, we end with an asymptote, and we are increasing, right? Tan on the run. So we go from negative 1 to 0 to 1. Okay, so now that we've adjusted our x's, and we can go ahead and put those down here, right? Now we have to account for our y's, right? So adjust for y transformations. Transformations. Okay, so if I do negative 1/2 times an asymptote, that's still going to just be an asymptote, right? If I do negative 1/2 times negative 1, that makes it a positive half. If I do negative 1/2 times 0, that becomes 0. Negative 1/2 times 1 is negative 1/2. And again, anything times an asymptote is still just an asymptote. It's not going to change it from being undefined. Okay. All right, so let's go ahead and graph this beast. Notice our smallest measurement is pi's over 8. So I'm going to count by pi's over 8. So here's 1 pi over 8. And then 2 pi's over 8 is pi over 4. And that's my ending point, so I can go ahead and go in the other direction now. So negative pi over 8, negative pi over 4. Okay, so I know that my ending ones are my asymptotes, right? And then I'm going to go ahead and say this is 1, this is -1, and plot my points. So at negative pi over 8, I'm down at -1, 0, I'm at 0, and positive pi over 8, I'm up at positive 1. All right? All right, so there's our tangent curve. All right, so let's go ahead and answer any of the questions that we don't have filled in. I think we filled in that we had a reflection, a phase shift. So phase shift is, did I move this left or right? And I can see just by looking at my graph, I didn't, right? Because it's still centered here at 0, 0. The other way that I can look to see if I had a phase shift is go back to my original function and see if I added or subtracted inside the function. Here I did not, so I'm just going to put none. And then our vertical shift is if we add or subtract outside the function, right? And remember, this negative, that's a reflection. That's not a subtraction. That's stuck to our a value here. So we're not adding or subtracting out here or out front, so we have none. Another way to make sure we didn't have a vertical shift is notice our tangent value, our tangent curve, right? It always is centered at 0, 0. So if we would have moved this vertically up or vertically down, then that center point would not be at 0, 0. Okay? And then what I want to do is I want to go ahead and extend another period length, just to show y'all what that looks like when we do tangent. So we do it just like we have with sine and cosine, okay? So I need to repeat this same curve. So I already have my first asymptote, but I need to continue counting over so that I have 4 more additional points. So remember here we were counting by pi's over 8. So this is 1 pi over 8, 2 pi over 8. The next one would be 3 pi over 8. And then 4 pi over 8, which is pi over 2, right? 3 pi over 8, 4 pi over 8, 5 pi over 8, and then 6 pi over 8. And 6 pi over 8 is 3 pi over 4. Okay? So notice now I have my 5 points because I'm starting at the asymptote. So that's my 1, 2, 3, 4, 5. So this one's going to be the ending asymptote. And then I just mimic those same points. So at my first point after the asymptote, I should be down at -1. At pi over 2, I should be at 0. At 5 pi over 8, I should be up at 1. Right? And then I want to draw my curve. And I know it'd be really easy to just draw a straight line. Do your best to make it jog over a little bit in the middle. And the way that I do that is I kind of try to make this look like half of a parabola when I connect these. So it kind of looks a little bit curved. And then the same thing, I do kind of half of a parabola going the other way, just so that we get that little jog over shape in the middle. Okay? So if they ask you to graph a curve over 2 period lengths, or to select the correct graph over 2 period lengths, this is how you can do it. Okay? You could also extend it in the negative direction. Okay? All right, so I want you guys to try one. So even though you're not going to have this chart, you should be able to kind of mimic what I did on this side. You can write in a chart if you'd like one. But I do want you to find all of the same information here. Okay, and then you can graph it on the line that's given on page 4. So I marked out extend it 2 periods because I want to give y'all a practice problem. So for practice, let's do y is equal to 3 tangent of 1/2 x. Okay, so that is your practice problem. I want to see if you have vertical scaling. I want to see what the period is, let me know if there is a reflection. Here, let me just write this stuff in. So, vertical scaling, the period, reflections, phase shift, vertical shift, and then you can use the chart if you want. Okay, if you need the chart to, if you need an XY table to help you, you would adjust your X's, right? So then you would have the row that is your X's, and you've adjusted them for what you have going on right here, which is tangent of 1/2 X. And then you would lastly adjust for your Y's. So the only transformation on your Y's is then to take care of that 3 out front. Okay? All right, so I want y'all to go ahead and pause the video and give this a go. And if you get stuck or if you get finished and need to check yourself, let me know, and we'll go over it. Okay? Okay, so let's see how you did. We can see here that our A value is 3. That gives us our amplitude, or our vertical scaling. Absolute value of 3 is just 3, right? We can see that our B value is 1/2. So when we go to find our period, we do pi divided by the absolute value of 1/2, which is positive 1/2, which gives us, a period length of 2 pi, right? Notice there's no negative out front, so that means no reflection. There's no adding or subtracting inside the function, so no phase shift. And there's no adding or subtracting outside the function, so that means no vertical shift. Okay? So then what we want to do is go ahead and take whatever is inside our function and adjust our x's so that we get those really nice, pretty y values. Okay? So I'm going to take whatever's inside the tangent function, which here is 1/2 x, and I'm going to put it between our regular start and end cycle for tangent, which is negative pi over 2 to pi over 2. Okay, let's get this up. So in order to get x by itself, I need to multiply by 2 in all 3 areas. And in all 3 areas, my 2's are going to cancel out, which means that this function is going to fall between negative pi and positive pi, which makes sense, right? Because we have a 2 pi period here. So from negative pi to positive pi, it should be easy to see that our intermediate point here is 0. And then halfway between 0 and pi is pi over 2, right? So that means halfway between 0 and negative pi would be negative pi over 2. I fill in with my nice pretty y values that we know from our tangent curve, which say we start with an asymptote and then we go from -1 up to 0 up to 1 and end with an asymptote, right? So our tan on the run, sky's the limit, just running off to wherever he wants to go, right? And then our last column over here is to adjust for our y's. So here we're multiplying our y's by this 3. That doesn't change our asymptotes, but it does change 2 of our points, right? So you can definitely see the vertical scaling when we plot our points. It did get stretched because now it's going from -3 to 0 up to +3. Okay? Make sure you draw in your dotted lines where your asymptotes belong. Okay? All right, so hopefully that wasn't too bad. So that's tangent. Same process, just shorter period, right? And we say vertical scaling instead of amplitude. So now what I want to show you is what cotangent looks like. And cotangent looks very similar to tangent because of the reciprocal identity. Because of reciprocal identity, where tangent is 0, cotangent will be undefined, right? So cotangent is defined as x over y, right? Or we can define this as, 1 over tangent x. What I think is easier to find is just the reciprocal of tangent, because now we already have nice tangent values, right? We're just calculating the x over the y instead of the y over the x. Now, this does change things a little bit. Let me find where's my unit circle? All right, so when we were dealing with tangent, remember, we had an issue at pi over 2 and negative pi over 2. And the reasons that we had issues with those two values is because that's where our x values were 0. And when we calculate tangent, our x values are in the denominator, right? So that makes our tangent value undefined at 3 pi over 2 or negative pi over 2, however you want to label it, and at pi over 2. So that's why our tangent had to run just half a cycle, right? We could run half a cycle here, or we could run half a cycle on this side, which we chose to do the right side. So our tangent went from negative pi over 2 up to pi over 2, right? Now, when we start talking about the reciprocal, these two values no longer give us issues, because when we do cotangent, we're going to be doing the x divided by the y. So this one would just equal 0. It's not an issue for cotangent, right? And the same thing down here. This one would be 0 divided by negative 1, which would just be 0. So this one's not an issue for cotangent. Where we end up having issues for cotangent is out here where the y's are 0, right? Because now when we calculate cotangent, if we do our x divided by y, right, we get an undefined value at 0, right, or 2 pi, however you want to label it, at 0 here. We also get an undefined value at pi, because if we do our x divided by our y, we get a 0 on the bottom. See? So for cotangent, again, we're just going to have a half cycle. It's not going to go a 2 pi period. We're just going to have a pi length period. But instead of it running the same as tangent, whereas tangent went from negative pi over 2 up to pi over 2, our cotangent is either the top half of the circle, right, between the two values that give us asymptotes, or the bottom half of the cycle. Okay? So what we want to use is we want to use the top half of the circle. So we'll again start at an asymptote, but then when we calculate cotangent of pi over 4, this is still going to give us a nice 1, right? When we calculate cotangent of pi over 2, that's just going to be 0, right? Because where it was undefined, when we do the reciprocal, it just becomes 0. And then 3 pi over 4, this again is just going to give me a negative 1. And then when I come down to pi, this is just going to give me my last asymptote. Okay? So cotangent is very similar in that we're only going halfway around the circle. We're still using our 5 points. We're still starting and stopping with an asymptote. It's just we're starting and stopping at different places. So here we're going to start at 0 and go to pi, whereas with tangent we started at negative pi over 2 and went up to pi over 2. Okay, does that make sense? So let's see if I can fill in. This is going to kind of explain that with the little chart here. So let's skip this stuff and go down to the chart. So if I pick, just going around the circle, 0 and then pi over 4 and then pi over 2, 3 pi's over 4, and pi. Okay, our tangent values as we go around here, let's see if I can get both of these on here. Our tangent values as we go around the circle, at 0, remember our tangent value here, y over x, was just 0, because we have 0 over 1, right? At pi over 4, we had the same number divided by the same, right? Same over same equals 1. And then at pi over 2, this is where we got an undefined, right? Because we were doing 1 over 0, which gave us our asymptote, right? At 3 pi over 4, if we're doing tangent, I have the same over the negative of the same, which gives us a negative 1. And then at pi, again, if I do y over negative 1, that just gives me a 0. Okay, so I'm just using these top 5, but I'm starting off with the tangent value. And then I'm just going to invert them, right? Because we know that cotangent x is 1 over tangent x. So that means we're at 0. This used to be 0. If I flip this and I do 1 over 0, now my values that used to be 0 are going to be my undefined values. Or in other words, the places where I now have an asymptote. Okay? If I look at pi over 4, if I have the same number over the same number, even if I do the reciprocal, that's still going to be 1, right? Our asymptote here, I had an asymptote here because I did 1 over 0. But if I flip it and I do 0 over 1, that's now just going to be 0. Here, if I flip these numbers, or even do the reciprocal of negative 1, I'm still just going to get negative 1. And then when I do the reciprocal of 0 over negative 1, negative 1 over 0, right? Or the inverse, the reciprocal of 0 is now going to be undefined, which then gives me my asymptote. Okay, so this is just explaining where we come up with our nice cotangent values. Okay, so for cotangent, let's go ahead and graph it, and then we'll talk about its properties. And then I'll do an example, and we'll call it a day. Okay, so this is going to run from 0 to pi. So 0 to pi, I'm going to do pi's over 4. So here's pi over 4. 2 pi over 4 is pi over 2. And then 3 pi's over 4. And then 4 pi's over 4, which is just pi. So you can see we're going to have an asymptote here at 0. So I'm just going to put it on top of that y-axis. We have another asymptote at pi. And then I can just fill in with my other values. Let's say this is 1, this is negative 1. So at pi over 4, I'm up at 1. At pi over 2, I'm at 0. And at 3 pi over 4, I'm down at negative 1. So notice this makes the same type of little swooshy swoosh, swooshy swoosh, as our tangent, except instead of whereas tangent is increasing, right? Tan on the run, sky's the limit, goes from negative 1, 0, 1, keeps going up. Notice cotangent is a decreasing, right? Meaning it's going down. So the way that I recall this, let me just put it over here to the side, is that when I think about tangent goes from negative pi over 2 to pi over 2, right? That's our 1 pi period length. Okay, and notice I use parentheses because we can't include those endpoints because they have asymptotes, right? And we call this one tan on the run, right? Because it curves up. Sky is the limit, right? So we go from an asymptote to negative 1 to 0 to 1, and then we end with an asymptote, right? Now cotangent, the way that I remember this one, and this one goes from 0 to pi, is I'm going to say that cotangent, or cot, sounds like caught. Like if this guy's out on the run, right? We're talking about the tan on the run, or the band on the run, or the man on the run, or whoever's on the run. If they get caught, well, it's just all downhill from there, right? So caught, we know that this one is a decreasing function. It's all downhill from there. We still start with an asymptote, but instead of starting negative and going up, because the sky's the limit when you're on the run, now that you've been caught, you're starting up high and you're going low. Your life is low, right? All right. So this is how I kind of shortcut remember the properties about these two graphs, okay? Notice they're so very similar. They start with an asymptote, they end with an asymptote. They still use 5 points, right? But tangent goes from negative pi over 2 to pi over 2, and it's increasing, meaning we start at negatives and go positive. Cotangent goes from 0 to pi, and it's decreasing, meaning we start at positives and go negative, okay? Everything else stays the same, okay? So when we come up with our coordinates of a regular cotangent graph, this is what we're looking for. We adjust our x's so that we can use these nice pretty values, which is asymptote to 1 to 0 to negative 1, and then we end with an asymptote, okay? All right, so let's do one example of a cotangent graph, and then I will let y'all get started on this homework, okay? All right, now this is very important. I would love for you to highlight this. Don't rely on a graphing calculator. Learn to recognize the shapes of each trig graph. On your exams, you are not going to be able to use a graphing calculator, okay? And I will be grading you on this whole process that we have been going through on these graphs. So if all you have are answers and there's no work shown, you will not receive credit. So make sure you know how to find out if there's vertical scaling, the period, the reflections, all that jazz, that you know how to adjust your x's and then how to adjust your y's and how to graph it, okay? Because that's how your tests will be graded. So let's go ahead and fill in what we know. The first thing that I know is that whatever's going on in here, because it's a cotangent, I need it to be between 0 and pi when I adjust these graphs, right? Because cotangent is between 0 and pi. So I'm going to go ahead and adjust my x's, which is whatever is inside my cotangent. So, I sure did write this so bad. I'm pretty sure I did this on the whole section. Okay, because we start and end with an asymptote, we should never put less than or equal to. And I'm pretty sure I did that this whole time. Okay, so I want it to be between 0 and pi, but we should be using a strict inequality here. Let me look back at my other ones. I bet I sure did. I sure did. Bah! Okay. So you might want to run back through this section, and everywhere where we adjusted the x's, these should be strict inequalities because they cannot equal the asymptote parts. Does that make sense? I feel yucky. I don't like that I did that. Okay, this one should be strict. Okay. So before the day's over, or pause it if you want to do it right now, go back through and everywhere where we adjusted the x's, make sure there is not an equal to bar under those inequalities. That's my bad. My bad. All right, so let's go ahead and adjust our x's so that we can use those nice cotangent, pretty y values. So the first thing I'm going to do is I'm going to subtract pi over 2 from everywhere. So 0 minus pi over 2 is pi over 2. In the middle, these just cancel. And then this is 1 pi over 2 minus half of pi over 2. So that's going to leave me with half of pi over 2. If you need to come over to the side and get a common denominator, you're welcome to do that. For the sake of time, I'm just going to go with it here. Okay. Oops, this is negative. All right. And then I need to get rid of that 2. Dividing by 2 is the same as multiplying by a half. So I'm going to do 1/2 times negative pi over 2, 1/2 times 2x, and 1/2 times pi over 2. Okay, so that way that cancels and just leaves me with an x in the middle. And on the sides, I have negative pi over 4 and positive pi over 4. Okay, so this is my start and end values. Now on the chart here, notice I only put 3 lines. That's because our starting and our ending values are always asymptotes. Okay. So just to kind of keep our strategy the same, I'm going to go ahead and write in 2 extra lines just so that we have them. So 1, 2, 3, 4, 5. Okay. So our starting is negative pi over 4. Our ending is pi over 4. The absolute middle is 0. And halfway between 0 and pi over 4 is pi over 8. Right. Again, you can just multiply this by a half. This is negative pi over 8. And then, now that we have adjusted for our nice cotangent values, we know that this starts with an asymptote. It ends with an asymptote. And because we're doing cotangent, that's cot. When you get cot, it's all downhill from there. So we start up at positive 1, then down to 0, then down to negative 1. Right? And then the last thing we need to do is adjust for our y. So I can see here this 3 tells me that I'm going to multiply my y's by 3. And then this tells me I'm going to add 1. And we always do it in PEMDAS operation, right? Please excuse my dear Aunt Sally. We do our multiplication before we do our vertical shift. Okay, so we're going to do, well, it doesn't matter what we do on the first one. This one's still going to be an asymptote, right? On the next one, we're going to do 3 times 1 and then add 1. So 3 times 1 is 3 plus 1 is 4. On the next one, we're going to do 3 times 0 plus 1. 3 times 0 is 0 plus 1 is 1. On the last one, we're going to do 3 times negative 1. So 3 times negative 1 is negative 3 plus 1 is negative 2. And then we end with an asymptote. Okay, so we're going to go ahead. And graph this. So let's put our points on here, and then we'll go back and answer all the questions that wanted us to know. Okay, so we have these are little bitty values. So negative pi over 8, negative pi over 4, pi over 8, and pi over 4. Okay, so we go ahead and draw in our asymptotes on the first and the last x values. And then we can see at negative pi over 8, we should be up at 4. 1, 2, 3, 4. At 0, we should be up at 1. And at pi over 8, we should be down at negative 2. Which is right in the middle of the number that I drew, right? All right, remember when we connect our dots, try to make it a little bit curved and head it out towards the asymptote. A little bit curved and towards the asymptote. Okay, so we can see our nice shape. And there's a couple of things we can see, right? Notice my vertical center is this point, and it's no longer at 0, 0, which means we must have had a vertical shift. Okay, so let's go back up here and see if we can figure out everything that has happened. So, first thing is vertical scaling. Vertical scaling we get by multiplying on the outside. That's our amplitude, right? So that's our 3, okay? So when we calculate for our vertical scaling, we do the absolute value of that A, which in this case would just be a positive 3. So we're vertical scaling by 3, okay? And then our period, our normal period length is pi, and we divide that by the absolute value of our B. So that gives us pi divided by our B value in here is 2, right? So we're going to do the absolute value of 2, which is just 2. So our period length is pi over 2, which if you look at our graph, going from negative quarter pi to positive quarter pi is a total distance of half pi, right? All right, looking for reflections, we're looking for a negative on our A, which here we do not have it, so no. Our A was a positive 3, so no reflection about the x-axis, okay? And then our phase shift. Now, our phase shift we can find a couple of different ways. We can either take the two values that are in here and divide off the 2 to see, you know, where we end up, or I can look at where we're starting here. We normally start at 0, right? And it's showing that we're starting at negative pi over 4. So going from 0 to negative pi over 4 tells me that we're going left pi over 4. Okay. Again, I'm going to go ahead and show you how to calculate the phase shift. If you want to calculate it using what's inside here. So the phase shift, we have 2x plus pi over 2, right? And in order to figure out how far left or right we've gone, we have to make sure that the number on the x is divided off. So in other words, if I factor off that 2, if I divide this by 2, I'm left with an x. If I divide pi over 2 by 2, I'm left with pi over 4, right? And then I can see, because x's are backwards, this tells me that I'm going left pi over 4. Okay, so this is just another way to calculate that phase shift that we got here. Okay, and then the last thing we look for is a vertical shift. Vertical shift we get from adding or subtracting outside the function. So if I go back up here and look at my original equation, right, I have that plus 1 out here. So that is my vertical shift. That tells me that we're going to go up 1. Okay. So you can see all of this on the graph. You can see that instead of it starting at 0, 0, our center point here is up at 1, which means we vertically moved up 1. And you can see the distance between that vertical center and the next point I plotted. Instead of it just being a distance of 1, it's actually a distance of 3, right? Which shows our vertical scaling. All right, so that is the end of section 4.3. So you should now be able to do that assignment on my math lab. There is also a worksheet that goes along with this section. And again, I am grading you on this entire process of, can you adjust your x's to find your 5 points, to put in your nice pretty y's, and then adjust for your y's and graph it. Okay, I'm looking to make sure that you can find your scaling or your amplitude, your period, and all the reflections, shifting, and left, right, up, down. Okay, so make sure that you're working those worksheets using the same steps and strategies that we did during the notes. Okay, if you have any questions, please let me know.